Hi and hello to everyone. In this video, we are going to discuss about the Booth algorithm, right? Okay. What is Booth algorithm? See, if you want to multiply two numbers, right? I take the one number as the multiplicand, another number as the multiplier. Okay. The notation used for the multiplicand is I am using the variable m. For the multiplier, I am using q. That is, if you want to multiply m with q, right, you will get the product. Okay, so in the Booth algorithm, we are going to treat even the multiplicand. If of n bit, it can be either positive or negative. Similarly, the multiplier can be of n bit, it can be either positive or negative. The product will be of 2n bits. Okay, right, and we can do the multiplication bit faster. That's the important thing about the Booth algorithm. Okay, before going into Booth algorithm, we have to understand how the normal multiplication works. Okay, how the normal multiplication works. We are taking this example. Let me say we are going to multiply minus 13 with plus 11. The answer would be in decimal. It is minus 143. Okay, so we have to represent minus 13. Okay, so please see these notes, right? See this note. You can understand how to represent minus 13. Okay, negative numbers are represented in 2's complement form. Since 13 is minus 13, I have written minus 13 here, it's a negative number. We are going to represent in 2's complement form. Because of the minus sign, I have to put the sign bit as 1. If the number is a positive number, the sign bit is 0. Okay, then for 13, we have to take 2's complement of 13, right? So what is 13? It is 1101. If you put the weights 8421, it's 1101. Taking 2's complement. What is 2's complement? It is nothing but 1's complement. You have to add 1, right? 1's complement means all your 1's will be converted to 0. 1 will be converted, and 0 will be converted to 1. So 1101 will become 0010. Okay, so this is the 1's complement of 13. Now we have to add 1, so I am putting plus 1. I am getting this answer. Okay, 0011. So what is final answer for minus 13 in 2's complement form? Since it is minus, I am using the sign bit as 1. Rest of the number, which is for 13's 2's complement, which is 0011. So this is minus 13 representation of minus 13 representation minus 13 represented in 2's complement form. Okay, fine. There is another way of taking 2's complement. Instead of doing taking 1's complement then adding 1, I can do it in another way. Like I will write the number. Okay, let me say what is 13. Okay, I will write the 13 in 5 bits. So this is 13 in 5 bits. Okay, now what I have to do is I have to move from the rightmost side, right? Okay, from this side I will be moving until I encounter first 1. If there is a 1 is there, okay, I will not disturb that 1. Okay, I will keep the 1 as it is. I'll keep the 1 as it is. Then rest of the number after the 1 I will take complement. Okay, that is for this number. These numbers I will take complement. Okay, so it would be 0 would become 1. This 1 will become 0. This 1 will become 0. Then it becomes. So this is the easy way of doing what I can say. This is minus 13. Okay, right? So I can give some example. If you suppose you have a number like this 1 1. Okay, let me take a number. Yes. Okay, so this is your binary number. It is asked to take 2's complement. So no need to take 1's complement, add 1. What I have to do? You have to start from the rightmost side until you see the first one. You should not disturb, right? Okay, you start from the rightmost side. We have 0, so we have to put the 0 as it is. Then we are getting the 1, so put this one, the first one as it is. Okay, then rest of the number. What is the rest of the number? These numbers. For this you take 1's complement, or just convert your zeros to 1 or 1 to 0. Okay, so right, so this is the easy way of doing. Okay, you keep this in mind. Either you can do in this method or you can opt for this way. It's up to you. Now coming back here, we have minus 13. So what is minus 13? We have just now seen 10011. What is plus 11? 11 in binary, it's a positive number. So 01011. Now if you multiply these two numbers, how will you multiply? Similar to your decimal multiplication, take each number from your multiplier and multiply with the multiplicand. Okay. So this is, I can say this is my multiplier. This is my multiplicand. Right. So what will happen if I multiply with 1 with the multiplicand? I will be getting 1 1 0 0 1. Okay, take this one, multiply with this, you're getting this. Okay, next take the next bit of the multiplier, multiply the multiplicand one, multiply the multiplicand. Okay, you'll be getting 1 1 0 0 1. Okay, next it's 0, so your next bit is 0. If you multiply 0 with the multiplicand, the answer would be 0. So it is 0 0 0 0 0. Then the next bit is 1. Multiply 1 with the multiplicand, you get the same thing, which is 1 1 0 0 1. Next take the 0, multiply. Next take 0 and multiply, you will be getting 0 0 0 0 0. Right? Okay. Okay, as I said, it is of 5 bits. The multiplicand is 5 bits, multiplier is 5 bits. Okay, so the result would be in 10 bits. Now we are going to see an important thing called sign extension. Sign extension. What is sign extension? Okay, it is, we can see these are the sign bits. These are the sign bits. Okay, so we have to extend it such that your final answer would be in 10 bits. Because you are taking multiplicand in 5 bits, multiplier in 5 bits, the final answer will be in 10 bits. 5 plus 5, it is 10 bits. Okay, so how to do that? You can see here, this number is of 5 bits. So I have to extend this one to 5 ones to the left side of it. This is called sign extension. I am using a different color. I am using a blue color. You see here, I am putting 5 ones in the appropriate position. Okay, next for this number, the sign bit is 1. I have to extend it as 5 ones. So I am putting 4 ones here, such that the final answer you would be getting should be in 10 bits. Okay, so what I do is I extend the first one, right? So I can say this is the number of bits is 10. For rest of this, since we are starting from here, we can stop here. Okay, so 4 ones I am adding. So for the next one, I am adding 3 zeros. For the next one, I am adding 2 ones. For the next one, I am adding 0. This is the sign extension. That is, I will extend the sign bit to appropriately the number of bits required in the result. Okay, now you can add things. Okay, just it's an addition. Okay, so 1 addition 1. Next, this is a different color. We use the using green color. 1, right? So 1 plus 1 is 2. 2 means in binary it is 0 1. The sum is 1. Carry. I am using red for the carry. Carry. This would be your carry. Okay, carry would be 1 1 1. So its sum is 0. Sum is 0. Carry would be 1. So 1 1. Sum would be 0. Carry would be 1. For triple 1, 1, you can see here for triple 1, 1 1 1 triple 1, it is 3. 3 in binary is 1 1. 3 in binary is 1 1. The sum is 1. Carry is 1. Again it's triple 1. The sum is 1. Carry is 1. Then triple 1. Sum is 1. Carry is 1. 4 ones. For 4 ones, We can see here for 4 ones it is 1 plus 1 plus 1, 4 ones 4. What is 4 in binary? 100, 100. Okay, 100 means I am putting 0 here, so I am putting 10 here, which is the carry is 10. 10 is 2. 10 is 2. Okay, so it is 10 is 2. So 2 plus 1 3, 4 plus 1 5. So it's 5. What is 5 in binary? It is 101, right? So it's 1. So 10 is coming here. So that's the carry. Carry is 10. Okay, so 10 is 2. 10 is 2. So it is 2 plus 1 3 plus 1 is 4. It's 5. 5 is 101. Okay, so 1. The carry is 10. The carry is 10. So we can ignore the carry. You can ignore the carry. So this number is your final answer. Okay, so we can clearly see it's we are getting the sign bit as, what we are getting? We are getting the sign bit as 1, right? Okay, this is my sign bit. The sign bit is 1. Okay, the sign bit is 1. So it's a negative number. If it is a negative number, for this entire number, how you have to interpret the result? We have to interpret the result as the 2's complement. How we will be interpreting? You can see here. I will do it here. Okay. As I said, the easiest way, you start from the right side until you see the first one, encounter the first one. Put 1 as that, as such. Then rest of the number you complement. Okay. So since it's okay, I do it here. Right. Starting from the right side, the first one, you keep the first one as it is. I'm putting the first one as it is. Then we have 0. So 0 will become 1. Then we have another 0 will become 1. Then we have another 0 will become 1. Then we have 3 ones are there. So we have 3 zeros. Then we have 0 will become 1. Then next 1 will become 0. Okay. So what is this number? This number, if you convert this binary to decimal, okay, like I can say it's 8, 4, 2, 1, 16, 32, 64, 128. Okay, so what is the number? It is 128 plus 15. 128 plus 8 plus 4 plus 2 plus 1. I think you will be getting 143. Since your answer is in sign bit is minus, 1, you can put minus 143. Okay, this is how your normal multiplication is done. Okay, right? Now we will go. Now only we are going into Booth algorithm. Okay, what is Booth algorithm? The idea behind Booth algorithm is, if the number is 30, you can see a large number of ones here. 4 ones are consecutively there. So if we have some numbers as consecutively 1, what happens? You can see clearly, whenever we have a 1, we are writing the number as it is. Whenever it is 0, we are putting only 0. Okay, so when more number of ones are there, many times you have to keep on adding. Okay, to solve this problem, Booth proposed that, he said that a number 32 can be said as 32 minus 2. Okay, so for 32 this is the binary value, so minus for 2 this is the binary value. If you subtract, we will be getting 30, number 30. Okay, he said that if you can code it, right, using Booth coding technique or Booth recoding technique, we can do things bit faster. That's the idea. You'll see that. Okay, select this example. Yeah, I think they are doing for this example. Okay, you see here, this is 45 and number 30. 45 and number 30. If you want to multiply, how we will be doing? Yes, we have to take each bit of the number in the multiplier, multiply with the multiplicand, and you have to keep on writing and you have to add things. Okay, so first I am taking the 0. First I am taking this first 0. So multiplying with the multiplicand, all will become 0. Okay, next I am taking the 1. Next I am taking the 1. It will become 1 0 1 1 0 1 0. Right? Can I keep repeating this? Okay, please follow this. Right? for third one, then next for the fourth one. Okay, we are done till the 4 ones have been completed. Next we are having 2 zeros, so everything will be 0. Then for the last 0, everything will be 0, right? So you have to keep on adding. So if you add 0, 1, 1, if you add 1 and 1, you will be getting 2. In a straight way. Good. Okay, so it is 0. If you add, you'll be getting 1. If you add this, you'll be getting 1. If you add this, okay, if you add these things, you'll be getting 2, which is 0. The carry would be 1. Then we have 4 ones. For 4 ones, it is 4. 4 is 100 in binary. 100 in binary. So we put 0 here. The carry is 10. Okay. 10 is 2. 10 is 2 in binary, right? So 2, 3, 4. Again we are getting 4. For 4, we can write 100. So 0 in the sum, 10 would be there in the carry, right? So if you do this, 10, 2 plus 1 3 plus 1 4 plus 1 5. So 5 is, sum is 1, carry is 10. Okay, right? Carry is 10. And one thing I want to say, even if you want to sign extend this, all are zeros, right? Since it's a positive number, all are 0. So we can make it and extend everything as 0. It won't impact. Okay, so that's why I left things as it is, right? Okay, if it is 0, if you extend, put zeros here, the answer won't change. When you have a 1 only here, if you have a 1 here, then your answer will be changing. Okay. So okay, if all 0, there is no need of sign extension. If all the values are zeros, no need to worry about the sign extension. Okay. Coming back to the addition, it is 10. It is 2 plus 1 3 plus 1 4. 4. So sum is 0. Sum is 0. Carry is 10. So 10 is 2. 10 is 2. 2 plus 1 is 3. 3 means 1 1. Sum is 1. Sum is 1. Carry is 1. Okay. 1 1 is 1 is 2. For 2 means sum is 0. Carry is 1. Sum is 0. Carry is 1. So it's 1. So again it's 1 here. 1 000. If I add, I'll get 1. For this 0, it's 0. It's 0. Okay, right? So if you convert this number to, your what I can say, to decimal, what you'll be getting? 45 multiplied with 30, you should be getting 1350. I leave it to you. You can cross check. This is 1350. Now the important idea is, you can clearly see whenever we have a large group of ones, we have to add these numbers. More number of, we have to repeat the multiplicand again and again. Okay, we have to repeat the multiplicand again and again. 4 times we are repeating. To solve this problem only, Booth has suggested go for the Booth recoding. What he has suggested is, you compare the bits of the multiplier. If the ith, we are comparing the I bit and I minus 1 bit. Okay, the present bit and the next bit in the order, right? If you are comparing, if both are 0, we just multiply 0 with the multiplicand. Okay, multiplicand is your m. Multiplicand is your m. Okay, so if it is the this bit, now the present bit is 0, the next bit is 1. So we have to multiply with 1 with m. So it is m. If the present bit is 1, the next bit is 0. It is minus 1 times m, so it is minus m. Present bit is 1, next bit is 0. It's 0. Okay. So minus 1 into m is minus m, 1 into m is m. This is all 0. So if it is minus m, the idea is represent m in 2's complement. That is, represent the multiplicand in 2's complement. Okay. Right. That's the idea. Okay. Now you will do the same example using Booth multiplier, right? Booth multiplier. What is the number we have taken? We have taken 45 multiplied with 30. 45 multiplied with 30. Okay. So 45, I am using the same. This is my 45. What is 30? The number 30 is 001110. This is number 30. Now I am using Booth recoding. Booth recoding. Booth recoding. What does Booth recoding says? You compare. I am taking an example. If this is I, this is I minus 1. So I have to compare this 0 with the next 0. I have to fill it here. Okay. If this is 0, the next is 0. I have to put 0. Okay. Compare this 0 with this 0. If you compare, you have to, this both are 0 means 0. Now compare this 0 with this 1. Okay. 0, 1 means you put 1. You can see here 0, 1 means you put 1. Okay. Next, it is 1, 1. It is 1, 1. 1, 1 means, what do you say? See, look at the table. 1, 1 means you put 0. Okay. Again it is 1, 1. Again it is 1, 1. You put 0. Again it is 1, 1. You put 0. What are you getting the next one? It's 1, 0. It's 1, 0. 1, 0 means, look at the table. It is 1, 0 means you put minus 1. You put minus 1. Then for the last one, you can assume the next bit to be 0. Okay, same. Okay, you can assume that 0. So that would be for the last bit 0. So for number 30, this is the Booth recoded value. Okay, so it is 0. So instead of 1, I can simply put plus 1, 0, plus 1, 000, minus 1, 0. Okay, so this is number 45. This is number 30 in Booth recoded. Okay, now we keep writing. Okay, just a simple multiplication, right? Can we do? So we start with 0. 0, if you multiply with it, you will be getting 0, 0. Okay, all will be 0, right? Just you take this 0, multiply with this entire thing. Okay, so it will be 0, 0, 0. Next you take minus 1 and multiply. Okay, this is your m, right? This is your m. It's all your m, multiplicand. Yeah, that's a multiplicand, right? So if it is minus 1, what will happen? It will become minus m. Minus m is nothing but writing in 2's complement form, right? So we have to write the multiplicand in 2's complement form. As I said, here should start from the right hand side. If it is 1, first one, until the first one you keep 1 as it is. For the rest of the number you take complement, right? Okay, what I have done for this number, since it is minus, we are going to multiply with the multiplicand. So minus 1 into m, it becomes minus m. So if this is your m, what is minus m? We have to write in m in 2's complement. What is 2's complement? From the right hand side until you see the first one, you have to use the same values, right? We are getting the first bit as 1, we are putting the same 1. For rest of the numbers, you take 1's complement, or just to convert the 0 to 1 or 1 to 0. So this 0 is converted to 1, 1 is converted to 0, 1 is converted to 0, 0 is converted to 1, 1 is converted to 0, 0 is converted to 1. Okay, then for zeros, what we can do? Okay, okay, right. And for 3 zeros, then for the plus 1, we can put it like this. Okay, for the plus 1, it would be 1, 0, 1, 1, 0, 1, 0. Okay, plus 1 into m, it is m. So I am writing the m as it is. Then for 0, for 0, it would be 0, 0, 0, 0, 0, 0, 0. Got it? Okay, so this is the idea, right? So simply speaking, if the number is 30, using booth recoding, I am recoding into this value. Whenever you see 0, that's no problem at all. We can put simply all zeros. If you put see -1, we have to write 2's complement. This is your, I can make a mark here. This is your 2's complement of m. Okay, what is your m? M is your, this is your m. This is your m. That's your multiplicand, right? That's your multiplicand. Okay, and if it is +1, you can see here +1, the same m is written. For -1 only, we have to write 2's complement. That is, you can see from the table. If it is +1, no problem, simply m. If it is -1, you have to represent m in 2's complement. Okay, that's what we have done. Now you can, now the important thing, we have to sign extend. Don't forget to sign extend. How many bits we are taking? We are taking number 45 in, I think, in 7 bits, right? And the number 30 is also encoded in, recoded in 7 bits. Okay, so we have 7 bits here, so I have to further add 7 more bits in the first row, right? Okay, so I'm using different color for that. So we see what are the sign bits. I can make a mark here. These are the sign bits. These are the sign bits. So you have to keep extending the sign bits such that the answer should be in 14 bits, right? Clear? So this is 7 bit, this is 7 bit. If I multiply two 7 bit numbers, the answer should be in 14 bits. Okay, so I'm extending the sign bit. So already 7 bits are there here, so I have to put 7 more zeros. So 0, 0, 0, 0, 0. Okay, 3 zeros, 5 zeros, 10, 6 and 7. Okay, next, what is the sign bit? For the next one, we have a sign bit as 1, so I can extend 6 bits, 6 ones are there. Then from the next line, I can sign bit is 0, I can extend by 5 zeros. For the next line, 4 zeros. For the next line, 3 zeros. For the next line, 2 zeros. Okay, right? Now if you add, your answer would be in 14 bits. Your answer would be in 14 bits. Clear? Right? So I keep adding. So it is 0, 1, 1, 0, 1, 1, 1. So 1, 1, if you add, the sum is 0. The carry is 1. This is your carry. I think I can use a different color. I am using black color for carry. Yeah, the carry is 1. So 1, 1. Sum is 0. Carry is 1. So triple 1. The sum is 0. Sorry, triple 1 is 3. The sum is 1. Carry is 1. Right, 1, 1. The sum is 0. The sum is 0. The carry is 1. 1, 1. The sum is 0. 1, 1 is 2. Okay, the sum is 0. The carry is 1. 1, 1. The sum is 0. The carry is 1. 1, 1. The sum is 0. The sum is 0. The carry is 1. Okay, we can ignore the carry because it is going into the 15th bit position, right? So the final answer is we are getting, 1 second, some mistake we have made. Let me check. So 7 zeros we have here. We have 7 zeros we have. Okay. Zero, 1, 1. Oh my god, yes, yeah, I got the idea. See, we forgot to add, we have forgot to add one row here. That's the issue here. See, we have 3 zeros, right? So we should have three rows of 0. That's the issue. Okay, quickly we'll solve that. Okay, excuse me. So what we should be getting? I think I can even delete these things. Okay, now yeah, see, if it is 0, then -1, I'm taking 2's complement of m. then for this 0, this 0, then for the third 0 I have to add, I have to bring 7 zeros here. Okay, this is what I left it out, right? For 1, as it is as the m is written as it is. For 0, these are the sign bits. Okay, now quickly we can extend the sign bit. So how many bits? The answer needed 14 bits. In the first row we can see we have the 7 0. So this is the sign bit. So I have to extend this 0 into 7 bits. Okay, right. So just to keep adding the sign bit, extending the sign bit. 3 zeros, 4, 5, 6, 7. Okay, then the next row we have the sign bit as 1. So we have to add, you have to extend by 6 ones, then extend by 5 zeros, then extend by 4 zeros, extend by 3 zeros, then extend by 2 zeros, then extend by 1 zero. Okay, now just keep adding. So it is 0, it is 1, it is 1, it is 0, it is 0, 1 1. If you add, the sum is 0, the carry is 1. Okay, so it is again the sum is 1. So next for the next column you can see 1 1. If you add, the sum is 0, the carry is 1. Okay, so 1 1 if you add, the sum is 1, the carry is 1. 1 1 is 3, sum is 1, carry is 1. So 1 1 if you add, the sum is 0, the carry is 1. So 1 1 we have, the sum is 1, the carry is 1. 1 1 we have, the sum is 0, the carry is 1. 1 1 we have, the sum is 0, the carry is 1. 1 1 we have, the sum is 0, the carry is 1. Okay, so this carry we can ignore because we are getting the answer, the entire stretch is in 14 bits. Okay, what is this number? If you convert this number, you should be, this is same as the one we worked out without Booth multiplication. Okay, that is your 1350. This is your 1350. Now you should be asking, what is the special about it? The only thing is, if you compare, can minimize and show. Yes, if we compare the normal multiply with the Booth multiplier, we can see we are repeating the multiplier 4 times, multiplicand 4 times here. Okay, so the more number of addition is required by your hardware. But if you see here, only 2 times. For -1 we are writing the m in 2's complement form. For the +1 we are writing the m in 1's complement form. I mean as it is. Okay, for +1 we are writing the m in as such, right? Okay, so the lesser number of times we are going to add. That is the advantage of going for Booth multiplier, right? Now we will look at another example. This example will wind up. Okay, you see we are taking a number 13 and -6. Okay, number 13 we are representing in binary, which is 0 1 1 0 1. For -6, so this is the, for -6 this is the binary representation. Okay, so that binary representation in 2's complement form. So if you want an idea what is 6 actually, represent 6 in 5 bits, it is 0 1 1 0. Yeah, 0 1 1 0. Okay, so this is +6. Okay, now if you want to take a 2's complement, what you have to do, as I said, we have to move it from the right side. The first bit is 0. Until you see the first one, you should not change anything. Okay, so the first one is here. Okay, so I am putting 0 1 as it is. Then after that first one you are seeing, this is the one we are seeing here. After that you have to change your zeros to 1 and 1 to 0. So the next one will become 0, the next 0 will become 1, the next 0 will become 1. This is easy way. Okay, right. So this is number 13 and -6 we are representing in 2's complement form. Okay, if you multiply, your answer should be in, you should be getting -78. Now using Booth recoding technique, what you have to do, we have to recode the multiplier, that is your 1 1 0 1 0. How will you recode? You compare this one with this. Okay, if they are same, your answer is, it is recoded to 0. Now you compare this 1 with 0. If it is 1 0, what does the table says? Booth recoding table says if it is 1 0, it is recoded as -1. It is recorded as -1. Next you compare this 0 with this 1. Okay, it is recorded 0 1 is recorded as +1. 1 0 is recorded as -1, right? Then for the last one we can assume the next to be 0, so 0 is compared with 0, so it is recorded as 0, right? So this is the booth recoding of -6. Okay, so we shall proceed quickly. So for 13 it is 0 1 1 0 1. Booth recoded of -6 is 0 -1 +1 -1 0. Okay, right? So what is the idea? If it is 0, we can simply put 0. If it is -1, we have to write 2's complement of this m. Okay, so this is your multiplicand, which is m. Okay, if it is +1, if this is +1, you can write the same m. If it is -1, you have to take 2's complement of this value, then have to add. Okay, so first bit is 0, so I can put 5 zeros. The next bit is -1, so I have to write for -m. For -m, it is nothing but 2's complement. The first one, till the first one you keep as it is, right? So first you are getting 1, keep the 1. For the rest of the number, for this part, you have to convert 0 to 1 and 1 to 0. Okay, so it will become 1 0 0 1. For +1, it will become 1 0 1 1 0. For -1, it will become yeah, you have to take 2's complement of m, so it is 1 1 0 0 1. Okay, 0. Okay, keep adding 1 and 1. If you add, the sum is 0, the carry is 1. The carry I would put here, right? Sorry. Okay, 1 1, the sum is 0, the carry is 1. 1 1, the sum is 0, carry is 1. 1 1 1, the sum is 1. 11, so sorry, once 11, 1 1 is 1 1, the sum is 1, the carry is 1. 1 1, the sum is 1, carry is 1. 1 0 0, the sum is 1 1. Okay, right? So this is what you are getting. Okay, so what is this answer? Yeah, yes. Here we messed up one thing. Yes, again, see, we missed out the sign extension. We missed out the sign extension, right? What is sign extension? Yeah, we have the sign bit. Okay, 0 1. Okay, don't forget to don't forget to extend the sign, right? Okay, so keep extending. It's 5 bit, so we should have the first row as 10 bits, right? Okay, so 5 zeros are there, so add, since sign bit is 0, add 5 more zeros. 2 3 4 5. So next row sign bit is 1, so add 4 ones. Next row sign bit is 0, add 3 zeros. Next row sign bit is 1, add 2 ones, so add 0. Okay, now you add everything. It's 0 1 0 1 1 is 2, which is 0. The carry is 1, which is 2. Carry is 1. 1 1 1 1 double, triple 1 is there, sum is 1, carry is 1. 1 1, the sum is 1, carry is 1. Double 1, the sum is 0, carry is 1. 1 1, sum is 1, carry is 1. 1 1, sum is 1, carry is 1. 1 1, sum is 1, carry is 1. Okay, so you can ignore this, because this entire thing is in, already we are getting the answer in 10 bits. Okay, so what is this number? It's in this number is in 2's complement form. Okay, because we can clearly see the sign bit is 1. This is the sign bit is 1. Since the sign bit is 1, Okay, we can consider that as a negative number. So the rest of the number you take 2's complement. If you take 2's complement, what is the idea? You have to go from the right side until you see the first one. You should not disturb, right? So it is 0, 1. After that you convert, after this one you convert all the zeros and ones to complement, right? Okay, so it will become 1, 1. Double 1 will become double 0, then 0 will become 1, then double will become double 0. Okay, this number is your, what is this number? This is your 78. Because of a sign bit is 1, we can say the answer is in minus 78. So this is minus 78 representation. Got it? Okay, this is how we are doing, right? Okay, hope it was useful, right? Any doubts you ask in the comment section. I'm very happy to help you, right? Thanks for listening.